Okay, we have part 2 of 2.3, the rational zero test. What's important about this rational zero test, and you can fill in these blanks from your book, but what's important about the rational zero test is this is what you get out of it. You get all of the possible zeros, everything that could possibly be an x-intercept, by putting the positive and negative factors of the constant over the factors of the leading coefficient. So on this first example, x cubed minus 3x minus 2, the constant term is 2, the leading coefficient is 1. So all of the possible solutions are positive and negative. The constant is either 1 or 2 because those are the factors. The leading coefficient is 1. Okay, so when we're looking at all the possible factors, we're looking at possible of 1, because 1 over 1, or the possibility of a positive negative 2. So there are 4 possibilities for real factors, real rational zeros of this picture. Well, if I don't have a picture to look at, the best I can do is just to start trying some and see if I come out with 0 as a remainder, because that means it is a factor, or if I come out with a number, which means it's just a point on the graph. So best way to do it is to pull out your calculator, and from the graph, make a best judgment of what you think an x might be, an x-intercept. So x cubed minus 3x minus 2. If I were to graph that, all right, I see that it hits over here, so that's probably negative 1. And it hits over here, and that's probably positive 2 of my choices. Now I know there's 3 zeros because that's what my 3 as a exponent tells me. And if I look here, it doesn't cross. Remember from before, that means a multiplicity of 2, so that one actually happens twice. So what we're going to do is we're just going to pick one of these points, and we're just going to go through our synthetic division and come up with the other factors. So it looks like 2 is going to definitely be a 0. So let's try 2. Set up our coefficients so that we have all positions represented, knowing that the last one is a remainder. So we're going to bring down the 1, we're going to multiply around, bring down, multiply around, bring down, multiply around, and we do get that f of 2 is a 0. But it also tells us that this leftover are my new coefficients of my next test value. And from the picture that we just saw, we probably want to test negative 1 as an x-intercept. So there's my negative 1. I'm going to test that as an x-intercept. So I'm going to bring down 1, multiply around, bring down, multiply around, and yes, indeed, it happens to be a 0. Now if I look at what was left over, remember this is my constant, this is my single term, I get x plus 1. And if I solve that, I get x is negative 1, showing that my rational zeros are 2, negative 1, and negative 1 is a double root. So this possible zeros, what it does is it narrows down the possibilities, and then when I look at the picture, it narrows it down even farther for me to choose or to pick one from. And if there's more than one, I get to use the result in the next step and the result in the final step, and it told me what all 3 rational real zeros were. On the page 6 of our notes, it says find the rational zeros of this polynomial. So we're going to go through the process and see what we can find. Constant term. So here's my constant. It's going to be 1 or 3. Those are the factors of 3. The factors of the leading coefficient is 1 and 2. Therefore, my list of possible factors are positive, negative 1, positive, negative 1, positive, negative 1/2, positive, negative 3, and positive, negative 3/2. So I have potentially 8 potential zeros. Now the reality is there's at most 3 real rational zeros. I have a potential of 8 to test from, but there's only a maximum of 3. I again would pull out my calculator. I would punch in the equation, 2x cubed, 3x squared, minus 8x plus 3, and I would narrow it down even some more. Let's see, it looks like possibly negative 3 is 1. So let's jump to there. Negative 3. All coefficients, every position accounted for. We know the last one is the remainder, and hopefully that remainder is going to come out to be a 0. So we are going to bring down, multiply around, bring down, multiply around, bring down, multiply around, and yay, yes, it worked. All right. Now I can try another one, knowing that this represents 2x squared minus 3x plus 1. I might be able to just factor this at that point, but to keep going with this same process, we're going to pick another possible 0, knowing that this last one hopefully is going to give us a remainder of 0. And if we go back to our picture, it looks like maybe 1 is going to work, so let's try 1. So we're using the results of the last one because we know it was factorable, or it went in evenly. Bring down, multiply around, bring down, multiply around, and yes, it gave me a 0. So now this is just 2x minus 1. So then 2x is 1, so x is 1/2. My zeros are negative 3, 1, and 1/2. Alright, on page 7, as you can see up here, we're really not going to be using this too much, but you can read through it. What I'd rather you focus on is this example down here. I would like you to try to find all of the real zeros that exist. So first of all, what we're going to do is find the possible zeros. Possible zeros are the factors of the constant over the factors of the leading coefficient. So the list is all positive, negative, and I could go 1, 1/2, 1/3, 1/6, 2. 2 over 2 is 1. I'm not going to write it twice. 2/3, and 2/6 is 1/3, and I'm not going to write it twice. So potentially we have 12 possible zeros. The calculator we're going to go to help narrow it down even more. And it looks like it's crossing between two things. If you're not sure, you can always zoom in and, take a look at it, right around the x-axis, see what we get. Oops. Okay. So we know this value is 1. And it looks like it's definitely not 1. It looks a little more than 1/2. It's definitely farther than 1/3 and 1/6. It's definitely not the 2. So you know, between 1/2 and 2/3, I'd probably pick 2/3 just because it does look like that it's more than 1/2. So if I pick 2/3 as my possible 0, set up the coefficients, all positions accounted for, bring down the 6, multiply 2/3 times 6, you should get 4, 0, multiply 3, 2/3 times 3 is 2, and we did get our remainder of 0. So 2/3 is the correct root that we found. Now if I look at the rest of this, this gives me 6x squared plus 3. If I tried to solve this, take out a 3 for a GCF, and now the 3 is not going to give me any solution. The 2x squared plus 1, well, that's x squared equals negative 1/2, and when I square root a negative, I get imaginaries. So the only real root, one real root, is 2/3. The other two were imaginary because we had at most 3. So this is an example where there's only one real root and the other two are imaginary. And that is the second part of 2.3.